The formation of a solution is an equilibrium process. If you add a solute that is soluble in a solvent, if you add that solute to the solvent, it will begin to dissolve. In the beginning, the only process that can occur is dissolution. After some time, dissolution is still occurring, but the solute particles can begin to recombine to form solute molecules, and those molecules begin to recrystallize out of solution. After some time, the solution reaches a dynamic equilibrium where the rates of dissolution and recrystallization are constant, and no more solute will dissolve at that temperature. A solution that has the solute and solvent in a dynamic equilibrium is said to be saturated. And if you add more solute, as I said, it will not dissolve. For gases, the saturation concentration depends on the temperature and the pressure. A solution that has less solute than can dissolve at that temperature is said to be unsaturated. More solute will not dissolve. A solution that has more solute than saturation should allow is said to be supersaturated. How do you make a solvent hold more solute? Well, solutions can be made saturated at non-room conditions and then allowed to come down to room temperature conditions slowly. Some solutes will get stuck in between the solvent particles, and as they do, the solution can become supersaturated, meaning that the solution actually holds more solute than can normally dissolve at that temperature. Supersaturated solutions are unstable, and they'll lose all the excess solute when disturbed. For example, if you shake a carbonated beverage, the excess CO2 will come out. Here we have a supersaturated solution of sodium acetate. It doesn't appear to be supersaturated on the left because it's clear. But if you add just one crystal of sodium acetate, crystallization occurs around that seed crystal, and this is actually a very rapid process, and the extra sodium acetate crashes out of solution because it was holding too much or more than would normally dissolve at that temperature. For solids, solubility is generally given in grams of solute that will dissolve in 100 grams of water. For most solids, the solubility of the solid increases as the temperature increases, and we can use solubility curves to predict whether a solution with a particular amount of solute dissolved in water is saturated, unsaturated, or supersaturated. Here we see some solubility curves. We have solubility on the y-axis and temperature on the left. So, for example, let's take potassium nitrate. So, the curve of potassium nitrate crosses the 50-gram line, let's say, at about, 33 degrees C. So if a potassium nitrate solution has less than 50 grams of potassium nitrate in 100 grams of water at 50 degrees C, then it would be unsaturated. If it has more than 50 grams of potassium nitrate per 100 grams of water at, let's say, around 34 degrees C, then it would be supersaturated. One method of purification by chemists is called recrystallization. In this process, a solid is dissolved in a hot solvent, and then the solution is allowed to cool. As the solution cools, the solid recrystallizes out of solution, and the impurities are left behind in the solvent.